initial position is 0,0,6 is a feet, and the acceleration at any time is 0,0,32, and this is feet per second square because they are working in the British custom system, in which the gravity is a typical projectile motion. So now I need to find the maximum height. So it's obvious that the trajectory of this rock describes a parabola, pero la parabola is 3-dimensional. Entonces I want to find the peak, so the highest value, and the maximum range, que es on the floor when the rock hit the floor. Okay, entonces this is easy because the only thing you should do is, in order to find the velocity at any time, well, you antiderivative. Antiderivative who? Antiderivative acceleration. Remember, the vector value function, we can apply calculus. And you can find derivative or antiderivative component by component, right? So basically is antiderivative of this vector and antiderivative 0 is constant, you know. And what constant? Well, the initial condition, and the initial condition is 16. Look, this is velocity, so antiderivative acceleration is velocity. Entonces 16,0 because the component in the y direction of the velocity is 0. Okay, it's given. I respect that. Now, comma, antiderivative negative 32 is negative 32t plus 64, que es the position, the initial position, ¿no? of the initial position, no, the initial velocity in the c direction. Entonces this is the vector value function associated with the velocity, no? Okay, it's the velocity. And the position, one more time, you apply the antiderivative. So, position at any time is the antiderivative of velocity. Actually, the only thing you should do is antiderivative this vector, 16, 0, and negative 32t positive. Now, position is at any time. Okay, antiderivative 16, the constant is 16t plus a constant, but the position, the initial position, the first component is 0. So no, that one, look here. Comma, 0. When I constant, but in this case the initial position is 0. Comma. Entonces antiderivative is a little bit more interesting, is is negative 32 t squared divided by 2, no? Plus 64t plus a constant, in this case is 6, because the position, initial position in the c component is 6. Entonces now 32 divided by 2 is 16, no? So you erase that part. You put negative 16. Negative 16 t squared. And this is the vector value function that describes the position, the displacement of that rock. Okay, free fall. So I want to investigate the maximum height. I pay attention specifically the component z, que es the vertical, the high component. Es a parabola. It's obvious. And this parabola have a vertex at the point. I can find the vertex using the formula que you use in algebra. O sea, A is negative 16, B is 64, and C is 6. And the formula for the vertex is H equal minus B over 2A. There are many ways to do this, but it's one possibility. It's minus B, que es 64, divided by 2 times negative 16. Entonces, negative 64. Okay, bueno, negative, double negative become positive. It's obvious. The answer is positive. Positive what? Positive 64 divided by 32, no? 2. And what mean that 2? Well, let's make H value. My H is the T in that case. So basically our parabola, okay, by the way, start in 6, no? Okay, see, we are doing the sketch in 3D. This is X, this is Y, this is Z. And our parabola, I don't know exactly, but we can do it in this in algebra, sorry, if you want. Pero es supposed que es un point. Entonces, the important point for us is this point, que es the maximum height, and this point, que es the range. And we compute this time, no? This time, this time, this time, doesn't matter. Okay, this is 2 seconds because it's the time. If you want to plug it in, you plug it in, the position at 2 seconds vector is plugging in where? Here. And this vector value function is 32 because it's 16 times 2, no? 0, comma, and 7. And 7 is the maximum height. At this point is the point expressed not like a position vector, sino like a point 32, 0, 7. So we have the first answer. The first answer is maximum height is 7. Maximum height of the rock is 70 feet. Okay, now if you want to find the moment in which this happened at t equal 2 seconds, right? So you want to find the time in which the rock hit the floor. You take again this equation, minus 16 t squared plus 64 t plus 6, and you enforce it to be equal to 0, and you solve for t. You have 2 solutions, but one solution is positive, another solution is negative. I want the positive solution. Okay, guys, I skip the solution for the quadratic equation. No, you know that. The solution positive is important, is the time. Time is always positive. It's 4 point something, 4.09165. You round a little bit, 4.1 second. And 4.1 second, the rock hit the floor. So I want to find the position at that time in this vector value function. And the position is when you plug in 4.5 here, here, and here, give me obviously 65, 0, 0. And this 0 is expected, no? Because you enforce the situation to be 0. And 65 is the maximum range. So the maximum range, okay, by the way, is in this axis. Actually, the parabola no, it's not like that. It's like that. And this distance is 65. And this distance is 7. So you see, I don't know why, the problem say that the second component is always 0. Okay. 0 in the initial position and 0 in the velocity. So the answer is 65 feet. Any question? You follow me? Any question? Come on.
What the formula that says h equals negative b over 2a?
It's the vertex of the parabola, mister. Okay, the parabola, uh, uh, this is one possibility. Another possibility is, look, you took physics?
Yes.
Look, in the parabola, in the projective motion, you have the velocity in this direction is zero. So the velocity, no initial, no, sorry. The velocity, the component of the velocity z is equal to zero, exactly in the position at the maximum height. So another way easy, in my opinion, is when I did it in that way. That is a reason I explained. But I realized another way. Look, you take the velocity. The velocity gets this, sorry. You take minus 32t, 32t plus 64 equals 0. And you solve for t, obviously you get the same answer, 2 seconds. Right? Because in the peak of the parabola, there is the moment in which no increasing anymore the z. You know, it's the moment you stop increasing and now decreasing the height. It's the maximum height. Make sense?
Yes.
There are many ways. Using your imagination and using your skill in mathematics, algebra, something. All right. How do you get 4.1? Well, 4.1 was the solution. The solution of this quadratic equation. The solution, let me see where. There you go. I set up this quadratic equation because this is a moment in what the rock hit the floor. Because I put height 0. I solved this quadratic equation. If you want, I show you how you solve the quadratic equation. I suppose que no, no? Yes? Okay, no. Okay, David. Okay, let's move on to the next problem. See, you have no more question. This is application in kinematic of the application that you see before, but the project is new, no? Because it's vector value function. Okay. Okay, now the question is super easy. Question is about sketch the graph of this conic section case 4x squared plus 4y squared plus c squared equal ay. Quickly, without do anything, using intuition. What surface it is? Name, first name, and last name. Come on, everything is positive, everything is a square. What kind of figure it is? Well, while you thinking about this, let me try. You see a square, but you have y. It's not a square. Entonces now I suppose que this part represent the y translation. Entonces 4x squared es plus 4 factorization y squared minus 2y plus box. So the complete square plus c squared equal 0. Oh, no, equal 0, no, equal box. Equal box. Entonces now es obvio que es 1. Es obvio que the magic number que complete square is 1. Actually 4 here, because 1 times 4 is 4. Entonces ahora 4x squared plus 4y, what do you say? Ellipsoid, of course, absolutely, Álvaro. Minus 1 square plus c square equal 4. Now finally, remember, in standard, right hand side must be 1 divided by 4, everything. We have x squared over 4 plus y minus 1 squared over 4 plus No. When you divide by 4, it's appear for hello. Okay. Hello. You divide by 4. Let's do it in that way. By 4, by 4, by 4, and by 4. So we have x squared plus y minus 1 squared plus c squared over 4 equal 1. Nice. And you see clear like water que this is the ellipsoid, exactly, ellipsoid. And this ellipsoid is important the center. The center of the ellipsoid is located at the point 0, 1, 0, no? Because the only variable que have translation is y. If you want to do a roughly scale by hand, or you prefer doing it in GeoGebra, I prefer, of course. But let's do it in curiosity. 3 axes, quickly. X, Y, see? The famous point is the center is 0, 1, 0. Here, over there, here. So this distance is 1. And the radius, for example, si you assume que C es 0, the equation que stay is x squared minus plus y minus 1 squared equal 1. It's a circle. It's a circle. So in xy axis, it's a circle with the center is in 0, 1 and the radius 1, like that. In 3D, you can see like that. Okay? No, not good. Okay. Do you want to do in GeoGebra? Because maybe my paper in one piece of paper I do well, but this whiteboard is complicated because I am doing figure and I try to fix it. For example, I put here, I fix it. I set out doing this job. Okay, let me open GeoGebra. I will do the best, no? Okay. Let me try to do at the beginning from scratch at least one time in my life. Okay, share the screen to GeoGebra. Look, GeoGebra Classic. Do you see GeoGebra? And you click here and yes or no? Do you see or no? Answer me. Yes, good. You click here and 3D graphic. Personally, I don't like this plane, so I remove this plane. You right click and this plane no. And this is my famous axis X, Y, and Z. And you put equation. What equation? The original? Yeah, why not? Or the new one after the simplification, and you can. This is for x squared plus 4 y squared plus c squared equal 8y. Okay, ellipsoid, so obvious this ellipsoid. And the center of this ellipsoid is located at the point 0, 1, 0. Look at that center. If you want to change the color or you want to control the transparency of this ellipsoid, you go to the setting, right click here, setting, color. And you select another color maybe, no? And transparency here, but I don't know. Yeah. Oh, it's a new one. So you switching this, I don't know, sister. I don't know. The color, style, basic, name. Well, I don't remember. Okay. Okay, bueno, do you see the point? Look at the point. Do you see the point? And this point, for example, I setting y I put not only A, que es the name, the default your algebra have. You put the name and the value, or just the value, que es the point 0,0,1,0. Super, super, super easy. Yes or no? Yes, David say yes. Okay. Let's move on again to the whiteboard. So you have no question. You want to save the, you save, but I don't want to save. Only I close and no save. Okay. Okay, entonces now, next page. Okay, let me, don't forget to share the screen. Whiteboard. Here you go. Boom. Okay, super. I suppose, guys, can you see whiteboard, right? You see or no? Yes. Okay, erase.
Wait, Professor?
I'm waiting.
The sketch that you drew, would that be good enough for us if we submitted that?
Yeah. When you end the test, solve this problem, you are doing the graph using GeoGebra. And you,
Take a picture of it or something?
no. You can download. So
Oh,
then, you share, you press share option, try to investigate this. And you download like a picture, not like a folder, like a picture. And you convert it to format for the picture, or take a picture in your smartphone, but it's no, this software allow you convert to PDF. This, okay, you investigate, David, you investigate. Okay, entonces we finish the first page. Let's focus on the second page. This is the second page of the review. Okay, and this question number 9, using the scalar triple product to verify that the vector are coplanar. Okay, this is easy, relatively easy. Let me show you in detail this idea. Look, you know very well that the triple scalar product represents the volume of the one hypothetic box. So you have three vectors, U, V, and W, in 3D, of course. And this we form one parallelepiped, okay, represent the box here. Okay, and the volume of this parallelepiped we can compute it using the many way, the triple cross product. You, for example, you select U cross product V, and after dot product W, and you get the volume. Well, absolutely no. This is the number, right? And the actual value of this, give me a volume of this figure. In the case that they want to prove coplanar, what mean coplanar? Coplanar means that the point or the vector is in the same plane. Si es in the same plane, entonces the box, the volume is 0. Because there are no box. This idea is clear. Suppose we have a plane, coplanar. Coplanar means that these 3 points belong to the same plane. So we have no height, we have no volume. This is the idea. Entonces we can do in different way. Or you are doing the cross product first, and after the dot product, oh no! Or you compute the determinant, the 3 by 3, using this vector like a row of each determinant. Either way. In this case, in my opinion, it's much better, to practice a little bit the application in the calculus 3. We are doing by the cross product and dot product. do it step by step. Entonces, ijk, ijk, 1 for -7, que es the vector u, and 2, -1, 4, que es the vector b. Let's do it. Classical cross product. In the test on paper, I appreciate so much que you are doing by hand, ¿no? Entonces, I is 4, -7, chun chun, -1, and 4. Minus j. Remember, this is the only guy that is negative. The second one always happens. -7 to 4. Plus k. 1, 4. 2 negative. Okay. Now multiplication is 16 minus 7 because we have 3 negative, no? Negative, negative, and another negative when you go in that direction. Minus j, parenthesis, 4 plus 14. If you move in that direction. Yeah. This is always positive. Positive indicates that don't change the sign. You multiply and that's it. Okay, it's determinant 2 by 2, linear algebra, pre-calculus, easy piece, okay. Plus k, parenthesis, multiplication, this guy no change the sign, and multiplication, this guy change the sign. Actually, then it's -1, minus 8. Okay, so we have 9i minus 18j minus 9k. The student can prefer that notation, 9, -18, -9. It's a vector. It's a vector because it's cross product. Now perform finally dot product. So we are doing now the cross product dot product W, no? So as I copy here. I copy 9, -18, -9 dot product W. Who is W? W is 5, 9, -4. It's doing. It's a 45. Remember, component by component, you multiply 45. 45 positive. Well, 18 times 9 is minus 162. And this and this together is 36. And 36 plus 45 is exactly, no, the answer of this is -81. And -81 is not 0. Therefore, the idea, the answer for this question is these points are no coplanar. No coplanar. No coplanar. Because the triple cross product give me a value. So, okay, so what is the interpretation? Maybe one of the interpretation is the volume of the triplet cross product is 81. You take absolute value, so it's 81. So that means this is 81, not 0, because we have box, and these points are not coplanar. This point and this point and this point do not belong to the same plane. Treat each other. What is the positive? Because the triplet scalar product give me information for the volume, but you know, it's determinant. Entonces, determinant give me positive or give me negative. However, we are talking about geometric quantity, que es el volume. I never have no sense to talk about negative volume. So you find the actual value, right? Right? David say, okay. Okay, any question, guys? This is the moment to ask me any question. Okay. Let's move to the question 10, que es super elementary. Okay, I need collaboration. I need help. And the question 10 say, the question 10 say, do the sketch in 3D of this equation. Okay, the equation is z equal x squared. What do you think? What do you think? Paraboloide, hyperboloide, 1chi, 2chi con, I don't know, I'm lost. Tell me. Wow. Opinion. Nobody know everything. So we go to the GeoGebra to see the figure. You put the equation and that's it. In the three-dimensional space. Parábola. Parábola is no surface. Guys, you need to fix it, your vocabulary. Okay? And when you study calculus 2, parábola is a curve. Okay, no problem. Curve. Parábola. This is a parábola. It's obvious, right? But we are talking about surface. And surface, two-dimensional object. So no, when you say sketch the graph of the following in the 3D, of course, we are talking about 3D. You say parabola is wrong. Circle is wrong. No. In 3D, it's no circle, it's a sphere. Oh, it's a ball. Okay, but in this case, what is that? I understand que es parábola, pero en 2D. The question is not 2D, the question is 3D. Like that. Boom. Nobody know? Nobody know? Come on. You are a student. Si you make a mistake, no problema. Okay, this is Z-axis. And this is X-axis. And Y-axis is missing. Wow. What happened when the Y-axis is missing? You try to do the sketch of this parabola is something like that. Is extending along. And what is the technical name of this, David? David say, good idea. This is extending along the x-axis. So we have a family of parabola like that, right? And this is cylinder, guys. Cylinder. Remember, we have two kinds of surface. The cylinder, que is the first que I study, I don't know, the student don't remember, is when the one variable is missing. And when the one variable is missing, is extending along, exactly. He said, entonces cylinder. What kind of cylinder? Cylinder parabolic. Cylinder parabolic. O sea, no only los cilindros es circular, parabolic cylinder. Okay, no. I want to understand much better this. Entonces I open GeoGebra y I put equation and the story. Okay, but you need to remember definitely. This is a moment that you need to know that. Okay. Hello, surface. It's important in the next chapter, in the third chapter, in the second chapter. You need to know perfectly this. Let me try to do my best. Switching to GeoGebra. One more time. Do you see GeoGebra? Wow, it's raining too heavy here. But don't worry. I select 3D. View. 3D. No graphic, 3D. And no graphic in 2D, in 3D. Cool. Now do you see GeoGebra? Let me know, guys. Yes or no? Yes. Okay, cool. Now I here in the panel of algebra you put the equation. The equation is Z. C equal x squared. Bam! And you see the cylinder parabolic. along the y-axis, que es the green color axis. Super cool. Any question? No? No question. No. Heiner. Okay. Entonces now again, you analyze by hand, but you check it, double check it with the GeoGebra, no? And you the picture, the elegant picture, you using, let me see how, let me see, you select, view, let me see, it's raining really hard. And your house is also raining. The problem es que my office is en one terrace que I do, y entonces the ceiling es de aluminum, es isolated aluminum, ¿no? This is my private office. Entonces nada, when it's raining, it's no good. Okay, entonces let me try view, pero no view, don't view. Let me see setting tools. Well, you investigate how you save that field. Cool. Okay. Let's move on to the cool, David. Okay, let me one more time. The share whiteboard. Okay, next problem is about the Frenet-Serret formulas, no? But this is not complicated because the position vector is given. So find the curvature. Wow, curvature at 0. Wow, at t equals 0. Find the curvature. And what is the formula for the curvature? Curvature to any time is the absolute value of magnitude, the cross product R prime cross R double prime divided by magnitude R prime raised to the cube. This is the formula. So my position vector is sine t cosine t, a natural logarithm absolute value secant t. As always happens, you find first derivative, second derivative. No third derivative because there's no torsion. So you need to compute the torsion, yes, but no, and the curvature is only second derivative. You differentiate that derivative sine cosine. Derivative cosine is minus sine. And derivative natural logarithm is, let me try. Que the derivative of the natural logarithm is reciprocal, no? This is 1 over secant, no? Let me try to do separately. Derivative natural logarithm is reciprocal, and you apply the chain rule. So derivative secant is secant tangent. Wow. Therefore, secant cancel out, and it's tangent. Do you see that or not? Do you see that or not? Do you remember, right? The derivative is the natural logarithm, okay? We see it, okay. Okay, David always help me, no? But okay, guys, if you don't understand, I explain in different way, no? More clear, no? I suppose that you know a lot of things, no? I suppose that you remember the derivative of the most common function, calculus 1. Now, let's find the second derivative. Second derivative is differentiate component by component again, no? Derivative cosine is minus sine. Derivative sine is cosine, but we have a negative in the front, okay? And derivative tangent is secant squared. Cool. So I take advantage that the problem wants not only the curvature at any point. No. They want the curvature in zero. If they want the curvature in zero, I evaluate this in zero at t equals zero. Entonces my cross product is easy because it's numerical. No functions. Entonces you evaluate R prime en zero is cosine 0 is 1, sine 0 is 0, and tangent 0 is also 0. This is the velocity at t equals 0. And the acceleration at t equals 0, again, you evaluate 0. S 0, remember, sine 0 is 0. So this negative doesn't affect because 0 has no sign, you know. And negative 1, and secant 0, well, secant, remember, is the reciprocal of cosine. Si cosine is 1, 1 squares es 1. Entonces, actually, es 1 o es negative 1? No, es 1, right? Es 1. Positive 1. Everyone's following me so far? Now, why not? Perform the cross product. The cross product and compute the actual value. Well, after, let's do it step by step. Cross product first. Now the cross product is easy because it's just numerical value. ijk, the first vector is 1, 0, 0, and the second vector is 0, negative 1, and 1. Okay. I did that in that page. Again, so we happen I multiplication by the determinant is 0, 0, negative 1, 1 is this guy, minus j, 1, 0, 1, 1. Okay, and k positive is 1, 0, 0, negative. Okay, let's do it. This is 0, it's obvious 0, 0 I. 0, 0. And j, no, j is 1. It's negative 1j. Default, you suppose coefficient is 1. Plus, no, minus k. The vector is then, the vector is 0, negative 1, negative 1. This is the vector, that vector. The cross product in between first derivative or velocity and acceleration. And the magnitude of this es obvio que es square root 0 square plus negative 1 square plus 1 square. 0 is nothing, 1, negative 1 square is 1, 1 plus 1 is 2, the radical 2. Now, in order to find the curvature, we need the actual value of R prime. R prime is that vector. And 1, 0, 0, and actual value is, this is obvious 1. It's obvious. It's obvious 1. It's obvious 1. 1 square plus 0 square. Now, the curvature, let's come back at the beginning. The curvature is radical 2 divided by 1 cubic, and 1 cubic is 1, and it's radical 2. And the total curvature of this curve at t equals 0. It's our goal, no? In the program. Any question? Question? A ver. No. David said no. The rest is okay, guys? Remember, I recall one more time. This I say 1,000 times. Now 1,001. Monday is the last day. Monday, Monday at midnight. So basically, I don't care Monday. Tuesday in the morning, and I open my email. I see attachment your test, no, on paper, and submit in my lab the the test and homework online. Okay, so in the question 12 is about find the line que contain the plane this is perpendicular. Oh, okay, this is 12, ¿no? Okay, entonces es this. Give me one line, que es en parametric, 3 plus 5t. 2 minus 4t. And c minus 2 plus t. I suppose que t is from negative infinity to positive infinity because it's a line infinity in both directions. And one plane is given. Que es the plane, you don't see very well here, another plane. The plane is x plus y minus 3z equals 7. This is 7 here. Okay. And they want to find, okay, find the line which is find another line. So this is the given line. This is the given plane. You need to find the line which is containing. What mean containing? So I suppose that this is the plane. We are doing, guys, roughly sketch. No es super accuracy. Pero to have a qualitative idea, okay, about our problem, no? Okay, there you go. So this is a plane, hypothetically. This is a line. Whoa, suppose que es secant. Okay, and my goal is find the equation of the another line. Let me use another color containing in the plane. Containing is important, that word. And perpendicular, 90 degrees. Perpendicular, 90 degrees. Clear? Clear the idea? Do you understand what should I do? Well, no, you don't know the approach, but you know, clear. Okay. Entonces, to find the equation of the line, what information we need? To find the equation of the new line, what information we need? So we need to find the equation of the red line. What information we need? Help me. We need something. We need what? Nobody know? What information you need to find the equation of the line? 2 pieces of information we need.
A point.
A point, good. And?
A vector.
A vector. What vector? What is the name of this vector?
Direction
vector. Very well. And the plane, no. The plane is a point and normal vector, que es perpendicular to the plane. But the line, the answer was correct. The answer was, we need the point and we need the direction vector. So we need find the point at this point, by the way, no? Que es super easy. It's super easy because you plug it in the equation of the line, this, let me call line 1. It's a line 1. I need to find the equation of the new line I call line 2. You take the equation of the line 1 parameter, substitution in the plane, give me the t value, solve the t, and plug in again one component by component, and you find this point. So you have point, that we are doing in a few seconds, in my hand. How do you find the direction vector of the line 2? Direction vector, sorry. Of line 2. Some idea. Who help me to give me idea how you find direction vector of the line 2? And the keyword in this problem is perpendicular. This is the keyword.
With the cross.
Exactly. Cross product who? And between who?
Of the L1 vector and L2.
Cross product and between. Come on. Repeat again. I hear your voice intermittent.
L1 and L2.
Pero, okay. Okay, cross product R1, R2. R1 is equation, 3 equation. I need vector. Cross product in between vector and another vector. What is the vector? What vector this and what vector this? You realize okay, we have one vector, okay, direction vector. Let me use in blue color. This is direction vector of the line L1. By the way, guys, who is that? Help me. Component by component. Tan, comma, tan, comma, tan. Who is that?
5.
I, comma.
-4.
Comma.
1.
Super. This direction vector of this. These coefficients. Pam, pam, pam. But no. I discovered another 2. Ow. 5, 4. Okay, when I want to highlight something, I'm using this tool. 5 disappear. 4 disappear. Cool. Okay, the green don't disappear. Okay, now this is the first pro que participate in this game. Suppose que es this. Chum. And what is the second? What is the second? Because I need to find one vector here. Because I take advantage. This is a vector direction 2, no? Oh my God. Go ahead. Okay. Let me give the hint. Normal vector at the plane. Normal vector of the plane is 1, 1, -3. Yes or no? A normal vector of the plane look like that, perpendicular to the plane. Okay? And this vector, maybe in my case, I don't see clear, but they are perpendicular in 3D. And when you perform the cross product between B1 and M, give me B2. Okay? In 3D. Okay? Maybe this angle is not 90 degree. Okay? However, this angle is 90 degree. Okay? Because the line 2 is containing in this 90 degree. Now, when you perform the cross product, give me a one vector this vector lie on the plane. Make sense, right? Make sense, guys. Take advantage the property of the cross product. When you perform the cross product between two vectors, we get a new vector is perpendicular in 3D, of course, to the original vectors. Okay, entonces perform the, no, first of all, let's do in the point. The point first. The point is easy. Look, the point is I take that equation of the line number 1 is replace x, y, z in the plane. So we have 3 plus 5t plus y. Who is y? 2 minus 4t minus 3 times minus 2 plus t equals 7. Boom. Remove the parentheses y apply distributive property. Is 3 plus 5t plus 2 minus 4t plus 6 minus 3t equals 7. We combine like term 5, negative 4, and 3t is negative 2t. And this is 3 to is 11, no? Minus 2t is equal 7 minus 11, que es negative 4. T is 2. Using this t, in order to find the component, well, you plug it in again in the original line, x equal 3 times 5 times 2, 13. Y is equal to minus 4 times 2 is minus 6. And z is equal minus 2 plus 2, or is 0. Wow, entonces this is a famous point. This famous point is 13, negative 6, 0. Super cool. Okay, now what should I do? Find the direction vector B2. Okay, it's easy when you perform the cross product. The cross product between the normal vector. Okay, normal vector. Okay, basic somehow B2 is equal normal vector. Let me see, or B vector either way, B1 vector, cross product normal vector. Is again IJK. You see, again, this is important, the cross product. So this format, when I explained the first day, I say we are doing 3,000 times throughout the course, this cross product. And in the chapter 4, every day. And you copy 5, negative 4, 1, 1, 1, and negative 3. Wow. And you are doing that. I want to avoid that part. And the answer is B2 is a vector, que es 11, 16, and 9. Okay, and this is the direction vector of the new line gets red. Finally, the final answer. The final answer is set out the line to parametric equation, or either way. I prefer parametric. Parametric is the point, so x, y, and z. The point, remember, was 13 minus 6 and 0. And the direction vector is 11. Look at that. This 11, 16, and 9. Boom. Final answer. This is the parametric equation of the new line passing through the intersecting point in between the line 1 and the plane, and is perpendicular to both. Okay, perpendicular to well, containing in the plane. Make sense? All right, opinion. Do you have put 0 in the C? No. Hello, you guys. I accept any smart question. It's obvious because I do in my paper, this part disappeared. And the answer is only 90. But some students prefer keep this format. You put the point here and direction vector here, right? So either way, any smart way I accept. Correct and smart. You using your own style. Okay, let's do it the last. No, the last. We have 13 and 14. We did 12. Okay, no. I'm crazy. Okay, 13 is easy. It's easy. You have no question in the 12, guys. Everyone understand very well. Cool. Okay, delete. There you go. Let's move on to the 13. 13 is about the classical example. We have a line. The point is given, P. And one line is given. In vectorial equation, if you want, you write in parametric, no? X is equal 4 plus t. Y is equal 5 and not t. And z is equal 6 plus 2t. This is the equation of this line, L. I need to find the shorter distance. Shorter distance. There are many ways. I explain slider way, I explain projection, I explain the plane. But in my opinion, projection is better, right? So you declare, for example, you declare, for example, one point on the line here. I want to call Q. This is projection idea. And you find the vector PQ, QP, either way, PQ, okay, PQ, dije QP, ¿no? QP. And QP vector, you are doing this projection, que obviously is vertical projection, no horizontal. The reason que es vertical is because the unit vector que I will using is the direction vector, no? You take direction vector, que direction vector B is the vector 1, 0, 2, no? And you take this number, no? 1, 0, no t, and 2. This vector is in this direction. You find the unit vector. To find the unit vector, as always happens, you find the magnitude of this vector. Es obvio que es radical 5. And you divide by radical 5. So the unit vector and the direction is B vector divided by this. Entonces es, either way, you divide component by component, rationalize or no, it's no important, it's up to you. Radical 5, 0, 2 radical 5. Right? This is the unit vector. How do you know que es vertical projection or horizontal projection? Si the segment que you try to find, que es T, que es the shortest distance, is perpendicular to the unit vector que you have in your hand to project, es obvio que es cross product. Si you want to find that distance, no. Es dot product. But there are many ways. So I explain in class, you find the horizontal, subtracting the vector. It's one possibility. Oh, no, don't complicate your life. You find the vector PQ. Who is Q, first of all? Well, Q is Q. Q is, for example, I assume T equals 0, any value of T. Q is the point 4, 5, 6. And P no, P is given. P is 1, 2, 3. Right? Entonces the vector QP is subtracting 1 minus 4 is negative 3, 2 minus 5 is negative 3, 3 minus 6 is negative 3. Wow. 3 negative 3. Boom. Okay. See, you, for example, you take the opposite direction, doesn't change your answer. Suppose que you are doing no QP vector, you are doing PQ vector. Ok, entonces en opposite direction, entonces es 3, 3, 3 positive. But it doesn't matter. It's not important. It's not important. No important. No, don't frustrate for the direction, because actually the thing we try to find is distance. No. Okay, entonces you perform the cross product between. It doesn't matter. The vector que es -3, -3, -3, cross product, the unit vector in the direction que you want to project in perpendicular, que es 1 over radical 5, 0, 2 over radical 5. And you set up. This is the complicated part. Do it by hand. Okay, pero okay, it's easy. Or mechanical, no easy, mechanical. It's hard, it's long. I understand the difference between hard and complicated or long. You copy that, -3, -3, -3. And you copy here 1 over radical 5, 0 and 2 radical 5. And you perform this, determine I don't want to do this. No. The answer is -6 over radical 5, 3 over radical 5, 3 radical 5. Well, the only thing you should do is compute the distance, get the magnitude of this. Distance is square root. Square root this guy. Square root -6 over radical 5 square plus 3 over radical 5 square plus 3 over radical 5 square. And calculate. The answer is square root 54 over 5. Okay, the decimal approximation is 3.286. It is shorter distance. Cool, no problem. Everyone understand very well?
Professor. Was that the projection method?
Say again?
Was that the projection method?
This, what kind of projection matter? So it's important to understand, because you want to find the red distance, you need to find the vertical projection, because the red segment is perpendicular to the direction vector of the line. Another possibility, I don't know if it's your point, your question. Do you understand this or no?
Yes.
I answered your question or no?
Yeah, I was just asking if you were doing the projection method or not.
No, suppose that you don't like this way. Cool, no problem. You find another possibility, let me explain two possibilities. Nice and important possibility. Suppose that you don't like this way. Okay, no problem, I understand. You make a decision to find the projection horizontal, so the blue projection, that projection. You perform now the dot product between, so actually it's no cross product, it's dot product here in between the vector QP and the vector B. Of course, unit vector B, no? Unit vector B. And when you have this dot product as a number, and this number multiplied by the unit vector B, like a vector, give me a vector in this direction. And this is the projection horizontal. And you're subtracting QP minus this projection horizontal. Give me the projection vertical. But we are working in the world of the vector. Now you find the magnitude of this new vector, que is subtraction, QP minus projection horizontal, and you get the distance again. I guarantee 100% that you get the same answer. Cool? Okay, another possibility that I like so much is, do you follow me?
Yes.
Excellent. Another possibility, mister. is, okay. Well, take advantage not the unit vector b, you take the vector b. Okay, let me do another sketch because this sketch is too complicated. No, it's the same sketch, but only the line and the point. P and the line. Okay, so one possibility is take advantage the direction vector of this line. And we suppose that this is equal normal vector of the one hypothetic plane passing through this point. Okay, so now, look, to find the equation of the plane, we need two pieces of information. A normal vector, okay, suppose que es equal direction vector of the line, and a point P. Okay, that's the point that's given in the problem, right? So you find the equation of this plane and intersection between the line and the plane is too easy, and you find this famous point. I want to call A. So you know when you have the parametric equation for the line, you plug it into the plane. All right, and you find the point A. And after, finally, you find the distant point in between 2 points in the 3-dimensional space. Bang! And you get distance. Do you understand this idea? The idea is clear. You have a line. A line have direction vector. And direction vector, I suppose que es a normal vector de one hypothetic plane que contain the point P and this normal vector. Okay, so using this algebra, I get the equation of the plane. Good for me. Now, intersection, the line and the plane, similar to what I doing before, and you get the point A. Distance between A and P is the famous formula, distance formula, that you know very well. It's a big square root, x2 minus x1 square plus y2 minus y1 square plus c2 minus c1 square. What way you prefer? Projection horizontal, projection vertical, or plane? No idea. Okay, guys, time is over. It doesn't know over, but it's almost over. To say I have a complicated problem. It's the last one. Do you have questions about the equation 13 or no? Projection horizontal, projection vertical, or plane? Guy, answer me. The only guy, David is the only guy can talk to me. The rest stay quiet. Okay, let's find the equation of oscillator circle. Okay. Oscillator circle of the elixir. This is a problem in 2 dimensions. 9x squared plus 4y squared equals 36. It's elixir. Elixir en estándar, divided by 36, everything. Entonces, s squared over 4 plus y squared over 9 equal 1. Okay, cool. Now, immediately, let me try to do my best to do the graph of this. The center is in the origin. This is x-axis, y-axis. And this, the major axis is on the y-axis, is 3. So A is 3, B is 2, center 0, 0. My elixir look like that. This is 3, negative 3, 2, negative 2. Clear? And the parametric equation is, so you declare, for example, x over 2 squared plus y over 3 squared equal 1. And you suppose that x over 2 is cosine t. There are many ways to assume this, but I like this way. I don't know why. This is sine t. Therefore, x is equal to cosine t, and y is equal to 3 sine t. And t, the domain of t is from 0 to pi. Okay. Suppose que, for example, at t equals 0, well, okay, and this is parametric or vector value function, much better, is displacement at any time is equal to cosine t, comma 3 sine t. Same domain for this vector value function. Suppose at t equals 0, the vector is r and 0 is cosine 0 is 1, entonces 2, 0. And 2, 0 is that vector. Similar at pi over 2, 90 degree, the vector value function is cosine 0, cosine 90 degree is 0, and this is 3, que es that vector. Entonces, the problem say find this osculating circle. What is that? Osculating circle is, for example, in this part, in this point, the curvature, okay, I want to find in a few seconds, is higher than the curvature in this point. The curvature, well, imply we have a big curvature, osculating circle, I suppose. Here, no, we have a small osculating circle because the curvature in this case is low. Sorry, low curvature, high radius of curvature, que es reciprocal. The radius curvature is reciprocal curvature. Here the radius is low, and the radius curvature, sorry, kappa, is high. This idea is clear. Entonces, what is the formula? Well, to find the osculating circle, we need two pieces of information. We need the center, and we need the radio. And to find the radio, of course, we're using the curvature. I want to skip a lot of complicated, not complicated, but it's too big. Okay, first of all, the curvature, the formula is absolute value R prime cross R double prime divided by R prime cubic. Es la fórmula. Entonces you are doing exactly the same we are doing before. You differentiate one time. Let's do it quickly because it's easy. Derivative of t is minus 2 sine t, comma 3 cosine t. So derivative sine, the cosine is minus sine, and second derivative is minus 2 cosine, comma, minus 2, minus 2 cosine, minus 3 sine. Okay, and this is easy because it's two-dimensional problem. So when you find the cross product, actually we have a jk, but the component of the k is 0. We have no component of the k because it's 2D problem. It's minus 2 sine t, 3 cosine t, minus 2 cosine t, minus 3 sine t. Well, unbelievable. This cross product is constant, is equal to 6. So you try to investigate this. And the magnitude of the first derivative is, well, is square root 4 sine t plus 9 cosine t. Okay, entonces now our kappa, que curvature, is 6 divided by this guy. So this is 4 sine square t plus 9 cosine square t raised to the 3/2, no? Because the formula have cubic power and we have a square root, so it's 3/2. This is the formula in general for the kappa. However, kappa at 0, because they want the oscillated circle. Let me see the question. The point 2,0 gets t equals 0 and 0,3 gets pi over 2. You evaluate both. Kappa at 0 is 6 divided by 9 raised to the 3/2. Entonces, square root 9 is 3, and 3 to the third power is 27, 6 over 27. And reducing lowest term is 9 over 2. It's a curvature. And the radius of curvature at 0 is the reciprocal, 2 over 9. Okay. And the center of this oscillated circle, the center is located at the point 9 over 2. So, okay. What is the formula, guys? The formula to find the center is center. Intuition is the point 2,0, like a vector, just this point. Entonces now the center is located plus the radius curvature, que es 9 over 4, 9 over 2. Guys, this is arithmetic, hello. See, I can explain arithmetic in calculus 3, we are in big trouble. This is equivalent to say square root 9 cubic. Yes or no? Square root 9 is 3, and 3 to the third power is 27. Okay, focus on the important. You put in the calculator if you don't know. Entonces 9 over 2 es de a ver, let me see. The radius is 9 over 2, no? The radius is 9. No, sorry. I make a mistake here. I can make a mistake. This is 2 over 9. I make a mistake. The curvature is 2 over 9. Hello. And the radius is 9 over 2. And 9 over 2. So I'm using this radius from this point. Look, this is my elixir. Look. I have that point. Okay, 2,0. Like a vector. However, the normal vector is obvious using intuition. We can compute it if you want, because the vector in that direction is negative 1,0. How do you know that? Because this is the, let me see, this is the tangent vector here, unit tangent, and the unit normal is this. In this direction is negative I. Negative I. Okay, so now this is the formula, guys. The formula is center of the oscillated circle is the point we analyze plus radius of the oscillated circle multiplication by normal vector. A normal vector and using intuition is this. So now we compute that. It's easy. The center is located at the point. Negative 5 over 2, 0. O sea, negative 2.5. Negative 2.5. Therefore, the formula for the oscillated circle is x plus h or minus h is x paréntesis, x minus h, pero h es 5/2 square plus no k, entonces y square alone equal radius square, and radius square is this guy square, que es 81/2. Likewise, we can, and power 2, que es this point, que es the point 0,3, this is a vector, right? You find, o sea, in this case, you find the curvature at power 2, que es just plugging in, power 2 here in that formula. Look, in that formula. And we get 3/4. Now the radius of curvature at power 2 is the reciprocal, que es 4/3. And to find the center, we're using normal vector. Center is equal 0,3, que es this vector, plus normal radius curvature, que es 4/3, multiplication by normal vector, que normal vector, if the orientation of this curve is in this direction, the tangent vector is this, and the normal vector is that. Remember, all or both normal vector and tangent are unit vector, no? Only indicate direction. But this direction is 0,-1 because it's negative j in the y direction. Now the center, look at in this case at the vector 0,5/3. Now the second equation of the oscillator circle is x squared plus y minus 5/3 squared equal the radius square, that the radius square was 16/9, 16, oh, this is square, 16/9. Boom, this is the answer that they want. Oscillator circle at the point 0, t equals 0, oscillator circle at the point t equals pi. To make sure I did in decimals, not in GeoGebra. We can do that in this. One script can illustrate very well this idea. I want to show you this and end the story. Okay, let me show you. Let me try here. Boom. Share screen to decimals. Okay, there you go. Do you see decimals? Okay. Yes or no? Yes or no? Cool. Do you see, look, you see the leaks? Look at the leaks in red color. Bam. Okay, it's the giving at the beginning. The famous point is this. 2,0 and 3,0. And the oscillator circle is this. Okay, at the point 2,0, oscillator circle. Do you see clear that the radius big because the curvature is low? No. And this is the another oscillator circle. Yeah. Okay, the curvature is high and the radius curvature is low. Clear or no? Clear, David said. Okay, guys, do a good look. Remember, Monday is our final day for the chapter 1. And we start new chapter, super interesting chapter. And I suppose that you remember in the chapter 2 very well the surface classification, no? Ellipsoide, paraboloid, hyperboloid, etc. Okay, see you. Have a nice day. Mm-hmm.